Hi everyone, myself Jyoti Prasad from R&D Engineering College. So previous video we have discussed about error control codes. So we will see linear block codes. So previously we discussed about linear block codes. Today in this video we are going to see about the linear block codes problem. Like I said previously, this is a generator matrix. This is a format. How we are going to get check bits means C equal to M into P. I told you already. So how we are going to do this operation means, say check bits is a row vector C1, C2, C3 like that. So message bits also a row vector, which will be multiplied with parity matrix. So already I have told you the parity matrix size is K cross Q. So this row will multiply with the column. So already we know the matrix multiplication. This row will multiply with the this column. Okay, and the additions, all the additions are modulo 2 additions. So the first element m1 into p11 xr m2 with p21, second row first column. So likewise we will add all the elements. The resultant we can write as c1. So likewise we will perform c2 c3. So here I have taken for q equal to 3, I have taken c1 c2 c3, 3 check bits. So we are going to calculate C check bits like that. So let us see a problem. We will have a better idea. So see, the first generator matrix of our 6 comma 3 block code is given below. So this is a generator matrix. Like I said earlier, in the data of our linear block code, they may give generator matrix or parity check matrix. The three, among the three, any one matrix they may give. With along with that, they will give a hint about this. What is the size of the linear block code notation? They will definitely give you, or else we can assume, or else we can also get from this generator matrix what is the size of this linear block code. From the notation we can easily find out. So here they have given 6 comma 3 block code. Find all code vectors. They have asked to find out x code vector. Generator matrix they have given. So like I said, generator matrix will have format of two submatrices, ik and pk cross q. Ik pk cross q. So this here, if you see this one, this is identity matrix here. From this one, this is an identity matrix of 3, size 3. So I3 cross 3. So then we can say that three message bits are there. Ik, what is the size of the excuse me, what is the size of this identity matrix? 3, 3 cross 3. So 3 message bits. So n comma k, in this n comma k equal to 3 is explicitly we can know this one n comma k. So that is correct only. Ik means I3 correct only. So the second submatrix, this one is parity matrix. We can copy down same as it is. If you have doubt, you can verify. So this is a 3 cross 3 matrix. So what is the size of the parity matrix? K cross Q. K cross Q is a parity matrix size. We have, what is the Q value? N minus K is equal to Q value. What is N minus K? So 6 minus 3 is nothing but 3. That is nothing but Q value. So 3 is the K value. Q value is also 3. 3 cross 3. So this is correct only. We can proceed without any doubt. So first we have find out what is the parity matrix. If we know parity matrix, we can do the check bit operation. C equal to M into P. So we know what is the check bits. How to find out check bits? C equal to message bits matrix into parity matrix. Okay. So we will see how many check bits. Already I told you Q is equal to 3. Nothing but N minus K. So this row vector will contain, so row matrix will contain C1, C2, C3 undoubtedly. So how many message bits we have from this data? 3 message bits are there. So that's why M1, M2, M3 we can name it as like that. So from the given data from the generator matrix we have extracted P matrix. That one I will write here. C equal to M into P. So we will do this type of operation and we will find out C1, C2, C3 for this present problem. So C1 is nothing but M1 XR with 0 is 0. So that will be vanished. So the second one M2 with 1. M2 with 1. So this row and this column will combine the operation. So M2 into the second element. Second element is 1. So M2. The M3 into the third element. 1 is M3. So M2 XR M3 is the C1 equation. See, like that C2 equation, C3 equation we will get. See, we have, so see, sorry, I have taken four message bits here. Instead, we might have taken the three message bits here. Okay, from the combination of message bits only, we are getting the check bits. That is my intention to show you this diagram. So how to find out the code vector, combined code vector is nothing but, so they have not given any message combination as an input in the problem. So we have eight combinations with three bits, starting from triple zero to triple one. So eight combinations, which is highlighted in green color. Eight combinations will be there. For all the eight combinations, we will find out the check bits and code vector. It's an easy task, no need to hesitate. So first, if you see this C1, C2, C3. So if we have this equation C1, what is C1 is nothing but M2 XR M3. So from the previous slide, M2 XR operation with M3. That is the equation already we know. M2 XR with M3. So first we will see, we need only these two things for producing C1. C1 is this column. How to produce this C1 is nothing but XR operations, you know. So for different inputs, it will give output 1 0 1 for 1 0. It will give output 1. If same inputs, output is 0. Or else, if many multiple inputs are there, odd number of ones, output 1. Even number of ones, output 0. So we can go for two statements, nothing wrong. So here, first for 0 0. So 0 XR with 0, output is 0. 0 XR with 1, I told you already the output is 1. So output is 1. 1 is XR with 0, output is 1. 1 XR with 1, I had already told you even number of ones XR operation gives output 0. 0. So 0 with 0, 0 XR with 0, 0. 0 XR with 1, 1. 1 XR with 0, 1. So even number of ones, 1 XR with 1, 0. So likewise, I can find out C1. If I write C2 equation, if I know C2 equation, M1, M3 combination. So between these two things, if you do XR operation, and you should fill the C2 column. So likewise, column by column, C1 first, C2 first, C3 next. Then check bits will be finished. So once we have finished the check bits calculation C1, C2, C3, so if we place side by side, first message bits, then check bits. These are message bits, these are check bits. It will form the code vector. Like I said previously in introduction, the MST most significant bits will be message bits. So the right hand side in least significant bits positions, check bits will be there. So likewise, we will place next to next and we can form a entire code word. This is called as encoded word. This linear block code. For this input, message input triple zero. So this is a linear block code for the message 100. So likewise, we can understand. This is a code vector, finding code vector. We can also find out from the H matrix also. So we can also find out these things from H matrix. In the second problem, they have given H matrix. Like I said, they may give G matrix, generator matrix, parity matrix, or parity check matrix. I already told you. So this is two submatrices are there. So where this is the first submatrix is P transpose, and the second submatrix is IQ. Q check bits. எத்தனை check bits இருக்கு? That how that many. So here 7 minus 4, 3 check bits is there. So I3 correct. The data is correct. So we know P transpose from this one. This is P transpose. So this is P transpose. So first submatrix. So if I transpose that one again, see here three rows, four columns are there. Three rows, three cross four. See here, this one is four rows, three columns. I have done transpose of P transpose. P transpose, whole transpose is nothing but P. So I know P matrix. So if I know P matrix, what is the form of generator matrix? IK P. So IK is nothing but 4. So 4 cross 4. I 4 cross 4 is the identity matrix. I will place the parity matrix here. So I will get the generator matrix. Then I will get C equal to MP. check bits. So here message bits are 4. So that's why 4 zeros to 4 ones. So this is the input combination. So later we will form a code word here after finding the check bits from the equations what we got in the previous slide here from the C1, C2, C3. So combinedly we write as a code vector. So here we have given an extra column which is called as weight of a code. What is the weight of a code means number of ones in that code is 3. That is called weight of a code. How many number of ones in a code? Here in this code if we see 4 ones are there. So weight of the code is 4. So how to find out the error correction detection? So in the previous classes I have told you the error detection capability of a code can be defined as a linear block code can detect S errors if it satisfies D minimum greater than or equal to S plus 1. Here I want to say what is D minimum. So D minimum is nothing but a non-zero weight in this column is nothing but D minimum. The minimum distance non-zero, zero is not a weight. A non-zero weight, minimum weight is nothing but minimum Hamming distance, the D minimum. So the minimum Hamming distance is nothing but minimum of weight W of X column. So here we have weights 3, 4, 7. So the D minimum is 3. So we got one data. So 3 greater than or equal to S plus 1. If I substitute 3 greater than or equal to S plus 1. So I will go for trial and error method. I will substitute 1. 3 greater than 2. 3 greater than 2. True only, no problem. I will substitute 2 here. Yes, in place of yes, I will substitute 2. So 2 plus 1, 3. So 3 greater than or equal to 3. This is also correct. Up to this one, it will satisfy. After that, it will fail. So I will take the value of yes is nothing but 2. So it will correct single bit errors, 2 bit errors also. So two errors can be detected. The meaning of the statement is two errors can be detected. So likewise, same way, how many errors can be corrected? The formula is we can correct t errors. We can correct t errors if it satisfies this condition. D minimum greater than 2t plus 1. So what is t value? We will substitute. So 3 is greater than or equal to 2t plus 1. If I substitute 1 here, 2 into 1, 2 plus 1, 3. So 3 greater than 3. So that is the only thing it will satisfy. If I substitute 2 also, it will fail. So this code, linear block code, whatever in the given in data, it will correct only one error. So the error detection and correction capability from can be found out from these two formulas. Okay, so this is about linear block codes. Okay, the remaining things we will discuss in the next video. Thank you.